Welcome to today's crew conference discussion on AI in mining. My name's JT Clark. I'm a managing director and partner with BCG and a leader in our data science practice. Today I'd like to share with you some of our observations on the application of AI in mining around the world. Maybe starting with a little bit of context. The application of AI in mining has been accelerating around the world. Historically viewed as a laggard, the mining industry has rallied and deployed substantial investment into cutting-edge capability to improve their operations. AI is one of those fronts and has seen a rapid expansion of investment and maturing of capability. We have seen our clients progress up an S-curve of value, moving from basic visualization to complex integrated ops and AI solutions. However, there's more room to go. We need to continue to raise the bar to pivot from pursuing independent use cases with discrete sources of value to implementing full suites of AI-driven integrated operations. However, there is a real ceiling on value capture until your program in AI can bring together top-end capability, operational decision-making, and the expertise that resides in your organization. So let's talk a little bit about this S-curve and how we see others capturing value using AI. Typical starting point for capturing value is visualization. Using AI to explore data previously inaccessible, create insightful dashboards that are able to guide management decisions and inform operations. These dashboards are an important first step, provide familiarity with data, but are then quickly built on with use case specific and basic AI solutions. These solutions typically target isolated pockets of value with a one-off solution independently looking to improve a KPI or deliver specific value. Ultimately, these use cases pivot from static assessments to real-time solutions that are integrated with operations. With that real-time comes increased frequency and more potential value capture, but also increased complexity and the need to build trust and confidence with the organization. However, as we migrate from independent solutions to an integrated suite of solutions, we find not only are we able to build that trust, but we're also able to bring the full organization together, collectively leveraging the capability brought by AI, operating in coordination to maximize the value to the asset. Ultimately, we do see this technology progressing to closed-loop, high-frequency predictions with AI driving operational decisions throughout the mine. However, we've not yet seen that implemented. To bring this to life, let's take a moment and walk through one company's journey to deploy AI in their mine and mill. The context here is a copper mine that was already performing strongly. Benchmarking at a first quartile operations, they have a strong history of operational excellence and have implemented best practices throughout the mine and mill. However, they still felt there was the opportunity to capture more value from the ore body they're exploiting. We started out working with them by building a flotation optimization solution. This solution took real-time understanding of ore characteristics and operating conditions and provided a recommendation integrated with process controls that allowed those operations to achieve the maximum potential from their flotation and recovery. But it didn't stop there. Once completed, we identified the potential to extend this to grinding, to stockpile blending, to crushing, to drill and blast, and to maintenance operations, ultimately delivering an integrated suite of solutions operating in concert that delivered 10% throughput uplift and 5% incremental recovery, while establishing a foundation and platform for AI-driven integrated operations. So let's click into a little more about how that was done. As I mentioned, we started out focused on flotation optimization. Flotation, coupled with grinding, of course, are the key levers driving throughput and recovery. And by building a robust understanding of that equipment, we were able to understand how other pieces of the value chain could be adapted and enhanced to further improve the throughput and recovery achieved in the mill. The next logical step was for us to move one step upstream into the stockpile management. Here we look to deliver the best possible blend of ore to each grinding circuit, adapting the ore blend so that it was delivered to the grinding circuit best suited for throughput in those conditions. Additionally, we identified that there was mineralogy data embedded in the block model that we could not currently track through to our flotation and recovery. And by being able to draw that link, we'd be able to further enhance the recovery performance and throughput of the mill. While we could track that block model data by truckload, once the ore hit the stockpile, the data would become as jumbled as the ore in the stockpile. So as a solution, we ran 20,000 RFID tags through the entire system to be able to monitor the flow of material and build a model to understand exactly which ore characteristics were flowing into the mill. We found that for a 5-minute belt cut, you would have ore from over 150 different truckloads. Building this model was an important data unlock to further enhance our flotation and recovery models. But we didn't stop there. We worked with the crushers to improve their choke feed and set points to change with the fragmentation of changing blasting regimens. We worked with maintenance planning and scheduling to time the maintenance so that equipment was only out of service when it was least valuable to the integrated system. In this manner, we built a real-time integrated suite of operations optimization integrated with process controls, allowing the plant to respond rapidly to changing ore conditions and changing operating conditions. These real-time AI solutions can only be delivered if we move to a more advanced approach to AI in our facilities. Traditionally, data scientists will lean on a suite of tools or algorithms that can be referred to as a black box approach. You would have heard these names before: neural net, random forest, XGBoost. These are all black box solutions that can be applied to obtain a better understanding of historical performance. However, they have limitations that prevent them from being utilized in real-time optimization. In order to use data science in a real-time environment, we need to integrate data science with first principles or physics-based models. These physics-based models are what we have all used to run facilities to date. And by augmenting them and integrating them with data science, we create a more powerful tool that can be used in a real-time environment. Let's click into what some of the challenges are using black box models versus integrated solutions. A simple example would be that black box models don't understand basic physics principles, such as conservation of mass. While a black box will look and understand a pattern, an integrated physics-based model can understand conservation of mass and ensure that recommendations adhere to known physics laws. Additionally, black box models are restricted to operating conditions where we have extensive, high-quality historical data. However, our operations have to deal with whatever ore conditions and operating conditions are there presented at the moment, whether they are historically common or not. In order to get a recommendation for an unusual operating condition, you need to be able to look to the history to understand what might be a good recommendation and to integrate that understanding with physics principles to provide a solid recommendation to operators on how to operate. Only by bringing together an understanding of first principles and data science can we upgrade the recommendations and behavior of the operators. Ultimately, by delivering an integrated suite of AI solutions, integrated real-time with operations, and incorporating lots of operator and engineering team feedback to high-grade those models, we're able to build a very deep and robust understanding of the potential performance of the facility and how it will react to future ore conditions. This unlocks another source of value: AI-driven integrated operations. Now that we have upgraded our understanding of how the plant will perform, we are able to cast forward into the future to understand how the mill will respond to the future ore conditions and anticipate challenges and opportunities. These forecasts can be substantially better than our traditional forecasting techniques. In a period of rapidly changing ore conditions and challenging operating environments, one mine's forecast would be off as much as 10 or 15% from the actual capability. By using this AI suite of tools and building a forecasting engine around it, we were able to increase the forecast reliability and reduce the error to only 1.5%. With this increased precision, the mine planning teams, operations teams, and maintenance teams were better able to anticipate challenges, to prioritize equipment for maintenance, and to make decisions regarding future cutoff grade and resourcing requirements. By looking 4 to 6 weeks in the future, that team could plan better to unlock value that otherwise would have been lost to waste or poorly utilized equipment or inefficient maintenance schedules. As we've discussed this mine's journey up that S-curve of AI maturity and value capture, it's important to note that the journey is not yet over. There are still additional use cases, sources of value, and improvements to the AI models that can be delivered. But it is important to note that the site has embraced AI as a core part of their operations, and by bringing together their engineering expertise, AI capability, and operational discipline, they are able to extract the most value out of their AI solutions. As you reflect on this mine's journey and look at your own AI and data science programs, there are a few key factors you want to keep in mind to ensure that you're well prepared to capture full value. Ensure that your AI solutions are driving to real-time integration with operations and that they provide fully explainable solutions and causal models so that you can understand not only what the AI is recommending, but why it is recommending. This will enable the models to inform your operations in all operating conditions, not just those conditions where you have deep and extensive history, and ultimately will enable you to tie the AI into your integrated operations decision-making. Appreciate your time today and look forward to catching up with you in the future when we can all be at Crew in person again.